My name is Vandana Subroy, and I am a PhD student I'm still a PhD student at ARE. Just submitted my thesis last month for examination. Today I'm here to talk about the last chapter of my PhD thesis. And my thesis focuses on using non-market valuation and cost-benefit analysis for the efficient prioritization of threatened species conservation projects. And before I go any further, I'd like to acknowledge all those who've made this work possible. My supervisors, Abby, Marit, Dave, and Manda. They've all been so wonderful through all these years. Thank you all so much. And I also need to thank personnel at the BCA, especially Mr. Brett Beecham, and the Australian government, UWA, and the NESP for their generous financial support. So to put my research in context, conservation policies have multiple aspects: ecological, geographic, economic, and social, that must be taken into account for inclusive and optimal decision making on all these fronts. Now, cost-effectiveness analyses are often used to guide conservation policy decision-making. But what happens with cost-effectiveness analyses is that they take into account the ecological effectiveness of projects and their financial costs, but they neglect considering the social benefits and costs of these projects. And social benefits and costs include people's values for conservation outcomes and the means of achieving those outcomes. And research has shown that these values are significant and substantial. And because conservation often takes place in a social context, it's important to consider these social benefits and costs. Now, to that end, a benefit cost analysis is therefore most suitable most suitable tool to assess the selection of conservation policies, because if there is some way of monetizing the benefits and costs, then it's basically a straightforward comparison if the project should go ahead or not. Now, while BCAs have been used to demonstrate the need for species protection over development or to demonstrate the efficiency of strategies to conserve threatened species, they have not been used to compare and rank conservation projects, especially for threatened species recovery. And this is because the benefits of conservation projects are usually expressed in ecological terms, qualitative or quantitative. They're usually expressed ecologically, but they're rarely expressed in monetary equivalent terms. And it is a perceived difficulty of monetizing benefits of conservation projects that is basically a limiting factor of using BCAs as a decision-making tool, and instead, therefore, people prefer to use cost-effectiveness analysis. However, we hypothesize that the prioritization of conservation projects for threatened species recovery would change depending on the decision support tool used, cost-effectiveness analysis versus a benefit cost analysis. And it could also change depending on the inclusion or not of social values for strategies to achieve conservation outcomes, and also the risk of project failure in a benefit cost analysis. Now, to go about our objective, our project was carried out in collaboration with the Department of Biodiversity, Conservation and Attractions, and our case study area was Dryandra Woodland. It is a conservation site located 160 kilometers southeast of Perth in the Wheat Belt region. And as you can see from the picture, Dryandra Woodland is actually an important conservation site, but it's highly fragmented. And it is this fragmented nature that makes any sort of fox and feral cat control challenging, and there is a high enough concentration of foxes and feral cats in the regions because they can easily move between the farms and the conservation site. Now, a little bit about Dryandra Woodland. It is an important conservation site, home to over 200 vertebrate species, including the focal species of the site and of this project, There are Numbats and Woylies, and at the time of, in about 2016-2017, there were about 80 Numbats in Dryandra Woodland and 2,000 Woylies. And apart from climate change and other factors that include habitat loss and fragmentation, predation by foxes and feral cats is a key threat to the survival of Numbats and Woylies in Dryandra Woodland. Now the DBCA manages Dryandra Woodland, and it also implements fox and feral cat control at the woodland, and the primary strategy used to control foxes and feral cats in Dryandra Woodland is lethal baiting using the poison 1080. Other strategies that are implemented on a smaller scale or being considered for implementation include trapping using either leg hold or cage traps, predator exclusion fencing. And because Dryandra Woodland is so fragmented, and because foxes and feral cats can easily move between the woodland and the surrounding private land, the surrounding farms, another strategy, well, we don't have a picture for that, that can be implemented is integrated off-reserve management. What this includes is carrying out fox and feral cat control on the surrounding farms with the cooperation of the landholders. So it's either the landholders who will carry it out themselves, they will be given equipment, training, and possibly some financial incentives to do so, or it would involve the DBCA hiring professional shooters to carry out fox and feral cat control on the surrounding private land with the cooperation of the landholders. So the goal of our benefit cost analysis was to select the project that would provide the greatest net benefits, which in our case is the increased population of Numbats and Woylies over 25 years through the implementation of management that reduces foxes and feral cats in Dryandra Woodland. So the time frame that we chose for our benefit cost analysis is 25 years, with the starting year is 2017 and a default discount rate of 7%. So along with the DBCA, we sat with the DBCA and we asked them what would be the realistic combinations of the strategies that can be implemented in Dryandra Woodland apart from the baseline of 1080 baiting. So they came up with 7 of these strategies that they could realistically implement. And in this column there are the annual costs of the projects. These are all provided to us by the DBCA. Just to point out, projects 1, 5 and 7 that include fencing 1,000-hectare area of Dryandra Woodland would involve an additional $600,000 in capital costs to construct the fence. And project 2 that would involve fencing an 8,300-hectare area of the woodland would include an additional $2.4 million in capital costs to construct the fence, in addition to these annual costs. So now the benefits, like I said, of our projects are largely in the form of the socio-economic values of the focal species being protected. So they are Numbats and Woylies, and these benefits were estimated as people's willingness to pay for improvements in Numbat and Woylie populations, and also for fox and feral cat control strategies. And this was estimated using a discrete choice experiment. I won't go into details about the discrete choice experiment, we're just taking the results from that for the benefit cost analysis. I'll just provide this table which has the results of our discrete choice experiment. This was analyzed using a scale adjusted latent class model. So willingness to pay for Numbats is about the weighted average willingness to pay for Numbats is about 66 cents per Numbat and about 3 cents for a Woylie. I know a little less, but it adds up. And it's per household per year for 5 years. So now, in order to convert the benefits, to quantify the benefits, we have this willingness to pay, but we need to know what is the population of the species going to look over the time frame of our BCA. Now, we have different time frames for our BCA, which is 25 years, and the time frame for our discrete choice experiment was actually 5 years. So our benefits were calculated as people's willingness to pay over 5 years, whereas the costs were calculated over 25 years. So we had to resolve this in some way. Now we asked the DBCA, what is their estimate of the population of Numbats and Woylies in 25 years' time under different scenarios. So they went through, this table was got over a lot of discussions. So they provided us with a lower bound and an upper bound of the estimates, and we got an average value. Now this is in 25 years' time for the benefit cost analysis. Now, because we need to know what the population of Numbats and Woylies is going to be after 5 years, so we had to do a little bit of modeling, and we used a logistic growth model. We assumed the growth rate, we obtained the growth rate from trapping data that was already with the DBCA, and assumed that the carrying capacity for the model for different scenarios was equal to this maximum number that you see here, and from our model we got these values as the population of Numbats and Woylies after 5 years. So using this number and a value of the willingness to pay per Numbat, you can actually calculate the benefit for the entire population for 5 years, and then we obtain the discounting as well. But what we also considered are risks that the project does not deliver its intended benefits, and this risk was calculated as a combination of the technical, non-cooperation, socio-political, financial and managerial risk to the project expressed as percentages. And it is the formula. We again got the DBCA to give us these values that are basically in this column. So this number that you see is the value that was got after, by taking into account all these different risks for each project and calculating an overall risk for the project. And again, like for benefits and even for costs, even for risk, we had a range that would help us with the uncertainty analysis. Now a little bit about our results. I'm making very good time. So the present value of our cost range from $126,000 to about 4.4 project 4, which was 1080 baiting plus trapping, to $4.3 million for project 2, which was fencing an 8,300 hectare area of the woodland. And we found that the benefits of our project were pretty substantial themselves. About $910 million for Woylies for project 7, which was a combination of all the strategies, and the social values for project 2, which was just fencing on its own, was $803 million. And Of course, for project 3, this was not significantly different from 0. So this was essentially a 0. And I will come to this in a little bit as to, we assumed that the benefits for Numbats for project 2 were actually 0, but I'll just come back to it. Now, according to the cost effectiveness ratio, which was basically obtaining the most ecologically, which is to select the most ecologically effective project at the least cost. According to cost effectiveness ratio, these are the cost effectiveness ratios, and this is the ranking of the project that you would select were you using the cost effectiveness ratio. So the most suitable project then would be project 4, 1080 baiting plus trapping, followed by project 2 and followed, project 5 and followed by project 7. However, when you use your benefit cost analysis, that excludes social values for the predator control strategies and also project risk. So it's just taking into account what the monetary benefits of just Numbats and Woylies are. Then the ranking of the projects change. If you were using the benefit cost ratio, you would use the net present value. The project that delivers the greatest net benefits would be project 7, followed by project 6 and then project 5. So it's completely different depending on the metric you use. In fact, but the benefit cost results show that actually the benefit cost ratio for project 4 was the highest, 1080 baiting plus trapping. This is because the cost to implement this project was really low and the benefits were pretty substantial. But using the net present value, one would only select project 7 based on this. However, now when you include social values for predator control strategies in your calculation of benefits, but don't consider project risks, now again the ranking of the project is altered a little. While it was 1, 2, 3 in the previous slide, when you don't consider social values for predator control strategies, now the most favorable project is still project 7, but the second most favorable project now becomes project 2, because social values for fencing are pretty high, $803 million. Now when you take into account risk, not only social values but also the risk that the project fails to deliver its benefits, you get a completely different ranking again. Now the most favorable project becomes project 2, fencing an 8,300 hectare area. Then the second most is project 7, followed by project 5. And this is because the risk of project failure is slightly higher for project 7 compared to project 2, because there are more strategies, and strategies that include integrated off-reserve management have a higher risk of failure because of non-cooperation by the surrounding landholders. And again, well, it still holds that the benefit cost ratio for project 4 is still the highest, but now when you consider the benefits of the social values of Numbats, Woylies, and for predator control strategies and project risk, the most beneficial, the most suitable project to implement is project 2. Now we also carried out a sensitivity analysis for our data. We tested sensitivity to project cost, which was plus or minus 10% of the cost that was provided to us. We sensitivity to project benefits, the expected increases to Numbat and Woylie population, that's the range I showed you all before. Sensitivity to project risk, willingness to pay for Numbats, Woylies, and predator control strategies. We took the 95% confidence intervals as our range, and we also tested sensitivity to discount rate at the low and the high discount rate. Now, sensitivity analysis was carried out first of all individually at the by keeping the variables in turn at their low, average and high values, specific variables. But then we also carried out a full Monte Carlo sensitivity analysis using the at-risk software, where we could just model the change we could model the sensitivity for values in a combined manner. Now, according to our individual sensitivity analysis, we found that the net present value was most sensitive to willingness to pay. It was somewhat sensitive to project risk and project benefits, and it was least sensitive to project cost and discount rates. And indeed, our Monte Carlo sensitivity analysis actually showed us that our results were robust, and the probability that the net present value was less than 0 was 0 for all except for project 2, where there was just a low probability of it going below 0. But the ranking and at the mean and median net present value from the simulations was no different at their average values. So this is just a couple of graphs to show you the sensitivity of net present value to willingness to pay. So, like I said, net present value is most sensitive to willingness to pay. In fact, when you look at project 2, it moves from a rank of 4 at the lower value of willingness to pay to the most favorable at the average and the upper value of willingness to pay. And when you look at the sensitivity of net present value to the risk of project failure, it is project 5 that moves from a rank of 4 at the lower end of risk to a rank of 2 at the higher end of risk. And indeed, from a Monte Carlo sensitivity analysis, it picked out the variables that the results were most sensitive to, and that was actually willingness to pay for Woylies and for the predator control strategy, somewhat for the Numbats, but it was also slightly sensitive to the benefits as well and the risk of project failure. However, key results are that on average, all policy scenarios are highly attractive, so they can be implemented, they're feasible to implement. On average, benefits exceed cost by a factor of 700, and the most favorable project to implement changes depending on the decision support tool used, as well as the inclusion of social values for predator control strategies and the risk of project failure. Now, a little note about our most favorable project, that is fencing 8,300 hectares. Although it came out as the most favorable project, it is because there are very high values for fencing. $803 million, which was actually about 86% of the total benefits. So it's a little unusual. It's actually a very strange result that people value the strategy used to achieve the conservation outcomes rather than the conservation outcomes themselves. So 86% is quite high. And actually, the benefits of the increased Numbat and the increased population of Numbats is actually lower after 5 years for this strategy. If we were sort of it's actually lower after 5 years than the baseline of 1080 baiting. Now, this was something that we hadn't actually accounted for in our discrete choice experiment, that we didn't quantify people's preferences for lower values than a baseline and a base case of 1080 baiting. We always assume that the values would be more. So we just said the willingness to pay is 0, which is not necessarily true. But actually, even though we did put in a negative willingness to pay, it was still the best strategy. However, like I said, there are certain issues. And of course, our results also assume that the project budget is unlimited. Now, if that is not the case, then if our project budget is not unlimited, let's say it is fixed at about at $1.5 million, then the only projects that will actually be selected are projects 1, 4, and 5. And of them, project 5, of them you would select the project with the highest net present value, which would be project 5. So again, these are some cautions that we'd like to take. Now again, our results also depend on certain assumptions. We assume that we assumed a logistic growth model. We assumed that the growth rate was the same under different management options, and it was the same over time. Not necessarily the same. And again, the social preferences for fencing were independent of the fence size, which may not necessarily be true. So these are certain limitations in hindsight that you think you could have probably devised your discrete choice experiment a little differently. So, however, it does not change our discussions, our policy implications, which is that social benefits and costs are important. They're actually pretty substantial, and they must be considered for conservation policy decision making, because their exclusion can certainly alter the prioritization of projects, and they may lead to the selection of suboptimal policies. And because a benefit cost analysis can capture the social benefits and costs of conservation policies, it's a preferred tool, and it's probably a more recommended tool from our case study rather than a cost effectiveness analysis. So with that, I'm early. With that, I'll be happy to take questions. Thank you all.